The critical function of electrolytes, and therefore the critical function of water, is to allow cells to be able to generate energy and also maintain the stability of their wall or membrane. So an electrolyte is a chemical conductor. Unlike metals who conduct just the singular flow of electrons along a solid line. But when it comes to electrolytes, it's more of the movement of ions within a solution. So it's not a direct line or in a hard, particular wire. The body is a fluid-based environment. So particularly across membranes. So our cells are basically these little balloons that actually have a membrane. Now inside of them we also have organelles, which also have a membrane along them. So each one of these particular compartments, if you will, is where the ions of electrolytes are going to flow along the surface and in and out of those membranes. So it's important characteristic to understand that different electrolytes are needed and really should be the litmus test of which ones are selected for what are we going to try to achieve in the function of those cells or organelles. Now, interestingly enough, there's other elements such as zinc, copper, selenium, silicon, boron, and other various trace elements that can combine to really enhance the characteristics of other electrolytes because they have an electrical charge as well. So when they're combined in solution or their charge is lended to that solution, they're going to have a different effect, and oftentimes it can be enhancive. Now if you have the wrong ones in there in the wrong combination, it can actually impede that. So the key is balance and complementary charge characteristics of those that are combined. Now, there are various hormones that control this particular activity and concentration of electrolytes inside of the body. So it's a little bit more complex than just the mere presence of water and or electrolyte. Okay, so again, it's super important to have the correct type of electrolyte and that they are able to maintain their particular charge potential. So this is because when electrolytes lose their charge potential, the body's going to dump them. When they're no longer useful, they're going to dump them out of the kidney through the urine, or we're going to sweat them out through the skin. Now, when electrolytes also become too abundant relative to water volume and location in the body's also going to dump them via the kidneys and through the skin also. So this is why it's really important not to drive in large amounts of electrolytes, and particularly with various sugars in states of loss of water function, albeit whether it be sedentary or through states of exertion. The body has to process these molecules, these electrolytes and sugars and things like that, if you're choosing to put them in as a hydration strategy. So you have to keep in mind, it really boils down to what the body's ability is to maintain charge potential along membranes, both on the outside of the cell and the organelles inside of the cell. So dumping in excess of electrolyte and sugars really puts an excessive, unneeded taxation on the function of both electrolytes and water. So the vital and important thing about electrolytes is that they maintain voltage across the membranes. So membranes of your nerves, skeletal muscle, organ muscles such as the heart. So they maintain their own electrical current across themselves and impulses, but also across to other cells of different types, right? So this is not only limited to the exterior surface of their cells, but the surface of their organelles inside. So you have things like the mitochondria, the endoplasmic reticulum, the nucleus, all those things that you learned in biology. All of those are run on an energy and a current and a movement of ions. So huge influence on multiple levels. So when we think of electrolyte status, we don't want to just focus on it when it comes to hydration and bringing it in when it comes to that. We want to be thinking about electrolytes for their function function once they get into the body, into the circulation, out of the circulation, and into the cells. And what are they doing to intercellular water and their influences there? So their mission is not to just come into the body and hold on to water so you're technically hydrated, okay? So both inside of the cell, outside of the cell, in between the cells, all of that has a huge need for energy, movement, and flow, and electrolytes and their charge potential is what is responsible for that, particularly on their influence of water in its organization along those particular membranes. So you have two things that are merging together, electrolytes and water, to form a fantastic and very powerful battery. So it's, again, we don't want to focus on it just being the presence of those or the amount of those, but how they are functioning independently and collectively together. So not all electrolytes are created equal. Okay, so most electrolytes, they actually start out as a compound, which means they have generally a first and a last name. So an example would be sodium chloride or magnesium bicarbonate. Now, when these particular compounds, electrolytes, enter into a solution such as water, okay, or a solvent, they're going to separate into specific ions. And it's that separation that really lends to the properties of how they actually influence the environment that they're in, particularly in the body. So when we consume various electrolytes, it really means that it's important to focus on what that particular electrolyte compound, when it disassociates into solution, what type of effect that's going to have on the body. So a couple examples would be there's a dynamic difference between sodium chloride versus sodium bicarbonate versus sodium citrate. Same thing as difference between potassium chloride, potassium bicarbonate, and potassium citrate. They're all going to have a different effect once they're consumed in the body, and therefore their effect on water, fluid metabolism, and things like that. So it's really vital to understand the significance that comes from the type and combination of various electrolytes, and also their amount, their actual volume or weight that you're consuming. So the difference also comes down to application to particular states that the body is in, whether it's dynamically going to be a situation where we're under exertion through physical activity, or under a disease state such as a bacterial or a viral infection. All of these different combinations of electrolytes and status of the body is going to make all the difference in the world when it comes to selection and use of electrolytes. So they are not all created equal. When various electrolytes or trace minerals are properly combined into water and consumed into the body, they have the ability to impart a very powerful potential benefit. Now, this doesn't require large amounts, and in fact, oftentimes more dilute amounts can have an even more powerful effect in their charge potential if it has been influenced by other energetic forces such as electrical current, magnetic fields, vortex movement, even light and sound frequencies. So these elements that we call electrolytes can actually take upon themselves the properties of other energetic fields or influences when it comes to those things of electrical strength, magnetic strength, light frequencies, sound frequencies. Those things can have an influence on the electrolyte themselves and the movement characteristics that they were actually going to impart on the fluid environment that they're incorporated into.